On New Year's Day 2026, while most of us were celebrating with family and friends, counting down the final seconds of the old year, something was happening 550 kilometers above our heads that should concern every person on this planet. SpaceX's vice president of engineering made an announcement that sent shockwaves through the global space community. Starting immediately, the company will relocate 4,400 Starlink satellites to a lower orbit, not a routine adjustment, not a scheduled maintenance operation, an emergency reconfiguration. And the reason behind this unprecedented move reveals something that space agencies and satellite operators have been quietly worrying about for years. The collision risk in Earth's orbit has increased by 200% in just 6 months. Welcome back to the channel. This is not a distant problem that might affect future generations. This is not a theoretical concern being discussed in academic papers. This is happening right now. As you watch this video, thousands of objects are hurtling through space directly above your head at speeds that would make a bullet look like it was standing still. And what SpaceX revealed in their announcement raises a question that nobody in the space industry wants to answer publicly. Have we already crossed the point of no return? Have we already set in motion a chain of events that we cannot stop? Let me take you back 3 weeks before that New Year's announcement, December 17th, 2025. A date that might be remembered as one of the most significant moments in the history of space operations. A Starlink satellite designated 35956, launched just 1 month earlier in November, suddenly went dark. This was not a clean shutdown. This was not a controlled decommissioning at the end of a satellite's operational life. This was what engineers call an energetic event, a catastrophic failure. The spacecraft began venting propellant uncontrollably. Its attitude control system failed. It started tumbling end over end through space, no longer responding to commands from the ground. And as it tumbled, it released what SpaceX initially described as a small number of trackable objects. Within hours, commercial tracking company Leo Labs reported something far more alarming. Their radar systems were detecting not a small number of objects, but hundreds of debris fragments spreading outward from the location of the failed satellite. Each one of those fragments is now circling Earth at approximately 17,000 miles per hour. At that velocity, even a paint flake can punch through aluminum like a bullet through paper. A bolt can destroy a spacecraft. A piece of debris the size of a marble carries the kinetic energy of a hand grenade. And here's what keeps engineers and mission planners awake at night, staring at ceiling fans in the darkness. They still do not know exactly what happened to satellite 35956. Something inside the spacecraft itself failed catastrophically. The power system, the propulsion system, perhaps something as simple as a battery that overheated and triggered a thermal runaway. It could have been a manufacturing defect that slipped through quality control. It could have been a micrometeorite impact that damaged a critical component. It could have been a software glitch that caused the propulsion system to fire unexpectedly. Without being able to examine the wreckage, which is now scattered across hundreds of kilometers of orbital space, they may never know for certain. That uncertainty is terrifying for an industry that depends on reliability and predictability. If you do not know why something failed, you cannot prevent it from happening again. You cannot update your designs. You cannot improve your quality control. You cannot brief your engineers on what to avoid. You are flying blind, hoping the same failure mode does not strike another spacecraft. And SpaceX has nearly 10,000 satellites in orbit, 10,000 complex machines operating in the harsh environment of space, exposed to radiation, temperature extremes, micrometeorite bombardment, and all the other hazards that make space operations so challenging. If even a tiny percentage suffer similar failures, if even 1% of those satellites experience energetic events that create debris fields, the debris population in low Earth orbit could increase by catastrophic amounts almost overnight. Now let me give you a number that puts this entire situation into perspective. Between December 2024 and May 2025, a period of just 6 months, SpaceX conducted 144,000 collision avoidance maneuvers. Let that sink in for a moment. 144,000 times in 6 months, SpaceX had to fire thrusters on one of their satellites to move it out of the path of something that might hit it. That works out to approximately 800 maneuvers per day, one collision avoidance maneuver every 2 minutes, around the clock, 7 days a week, for 6 months straight. And that number represents a 200% increase from the previous 6-month period. The frequency of near misses is not just growing, it is accelerating exponentially. The traffic jam that experts have been warning about for decades is not coming. It is here. It is happening right now. And most people on Earth have no idea how close we are to a catastrophe that could change civilization. So what is SpaceX's solution to this increasingly dangerous situation? Move 4,400 satellites down from 550 kilometers altitude to 480 kilometers altitude. They are relocating half of their entire constellation, dropping those satellites 70 kilometers closer to Earth. The logic behind this decision seems counterintuitive at first. Why would you move satellites closer to Earth when you are worried about collisions? The answer lies in atmospheric drag. Even at 550 kilometers altitude, there are still traces of Earth's atmosphere. Not much. The air is thinner than any vacuum we can create in a laboratory on the ground, but it is not zero. Those few molecules of nitrogen and oxygen create drag on satellites as they orbit. Over time, that drag slows the satellites down, and when satellites slow down, they lose altitude. Eventually, they fall back into the denser atmosphere and burn up. At 550 kilometers, a dead satellite, one that can no longer maneuver or maintain its orbit, takes over 4 years to decay naturally. 4 years of a dead spacecraft tumbling through space, crossing the paths of thousands of active satellites, creating collision risk every single orbit. That is roughly 23,000 orbits before it finally falls low enough to burn up. 23,000 chances for something to go wrong. At 480 kilometers, the atmosphere is slightly denser. A dead satellite at that altitude takes only a few months to decay. An 80% reduction in the time debris remains in orbit. That is a massive improvement in terms of orbital safety. But there is another reason SpaceX is moving their satellites lower. Below 500 kilometers altitude, there are significantly fewer satellites and debris objects. It is simply less crowded down there. The traffic is lighter. The collision risk is inherently lower because there are fewer things to collide with. We are not solving the orbital debris problem with this move. Let me be very clear about that. We are running away from it. We are moving our assets to a safer neighborhood while the old neighborhood becomes increasingly dangerous. The debris at 550 kilometers does not disappear when Starlink moves out. It stays there, waiting for the next satellite constellation that decides to operate at that altitude. And here's what SpaceX is not saying loudly in their press releases. This entire relocation operation must be completed in 2026. The entire process of moving 4,400 satellites to new orbits, conducting tens of thousands of maneuvers, coordinating with other operators to avoid creating additional collision risks during the transition, all of it must happen within 12 months. Why the urgency? Why can this not be spread out over 2 or 3 years to reduce risk and operational complexity? The answer is the sun. Our star operates on an approximately 11-year cycle of activity. Solar maximum is when the sun is most active, producing more sunspots, more solar flares, more coronal mass ejections. Solar minimum is when the sun is quiet, its surface relatively calm. We have just passed through solar maximum. The sun has been very active for the past several years, and here is the crucial connection to orbital debris. When solar activity is high, it heats Earth's upper atmosphere. The atmosphere expands like a balloon being warmed. It puffs up, and that expanded atmosphere creates more drag on satellites in low Earth orbit. More drag means debris falls out of orbit faster. The high solar activity of the past few years has been cleaning low Earth orbit, pulling dead satellites and debris fragments down into the atmosphere where they burn up harmlessly. It has been a natural garbage collection system, working continuously at no cost to anyone. But starting in 2027, we enter solar minimum. The sun becomes quiet, solar activity drops. And when that happens, the upper atmosphere cools and contracts. It shrinks back down. Atmospheric density at satellite altitudes drops significantly. Suddenly, dead satellites that would have decayed in months now take years. Debris fragments that would have burned up in 2026 will still be circling Earth in 2030. Everything stays in orbit longer because there is less atmospheric drag to pull it down. If SpaceX does not complete this relocation before solar minimum hits, their satellites will be stuck in the most dangerous orbital zone for years. They will have missed their window. The natural cleaning cycle that has been helping manage orbital debris will pause, and the space environment will become progressively more dangerous with each passing month. This is a race against the sun itself, and the sun does not negotiate. It does not grant extensions. It follows its 11-year cycle regardless of human schedules and business plans. Now let us talk about the bigger picture. The context that makes this situation even more significant than a single company relocating its satellites. SpaceX currently operates approximately 9,300 active satellites. Stop and consider what that number means in historical context. For the entire history of the space age, from Sputnik in 1957 until just a few years ago, humanity had launched only a few thousand satellites total. Across 60 years of space exploration, across dozens of countries and hundreds of companies and space agencies, the total accumulated satellite population was measured in thousands. SpaceX has launched more satellites in the past 5 years than the entire world launched in the previous 6 decades combined. Here is an even more striking number. There are approximately 11,000 active satellites total in Earth orbit right now, operated by every nation and every company and every space agency on the planet. SpaceX owns 9,300 of them. One company, based in one country, founded by one entrepreneur, operates 85% of all active satellites humanity has ever placed in orbit. The entire rest of the world, every nation, every corporation, every space agency, every university, every military, every research institution combined, operates the other 15%. This is an unprecedented concentration of orbital infrastructure in the hands of a single entity. Nothing like this has ever existed before, and it raises profound questions about governance, security, and the future of space as a shared resource. At the United Nations Security Council meeting on December 29th, just days before the SpaceX announcement, China's representative was blunt. The unchecked proliferation of commercial satellite constellations by a certain country has given rise to pronounced safety and security challenges. They did not name SpaceX directly. They did not have to. Everyone in that room knew exactly what they were referring to. The elephant in the orbital space was impossible to ignore. The American response defended the Starlink constellation in practical terms. These satellites provide critical disaster preparedness capabilities. They enable search and rescue operations in remote areas. They deliver reliable communications to underserved communities that have never had broadband internet access. They connected Ukrainian forces during the Russian invasion when other communication systems failed. They provide internet to ships at sea and aircraft in flight and research stations in Antarctica. Both sides are right, and both sides are afraid of what comes next. Because here is the scenario that nobody wants to discuss openly in public forums. Last year, a research paper from a team of orbital mechanics specialists calculated what would happen if Earth suddenly lost the ability to actively control satellites in low Earth orbit. The cause could be anything: a massive solar flare that damages electronics, a coordinated cyber attack that takes down ground control systems, a geopolitical crisis that disrupts space operations. The specific cause does not matter for the calculation. The question they asked was simple and terrifying. Once we lose active control, once satellites can no longer perform collision avoidance maneuvers, how long before cascading collisions make certain orbital zones unusable? Their answer will haunt you: 3 days. In solar minimum conditions, with the current debris population and satellite density, we would have approximately 3 days before the first catastrophic collision triggers a chain reaction. One collision creates debris. That debris spreads out along the orbital path. It encounters other satellites. More collisions, more debris. Each collision multiplies the problem because debris does not come in single pieces. A satellite hit by a fragment does not just develop a hole. It shatters into hundreds or thousands of additional fragments, each one capable of causing another collision. This is what scientists call Kessler syndrome, named after NASA scientist Donald Kessler, who first described the phenomenon in 1978. Kessler was not making wild predictions or engaging in science fiction. He was doing careful mathematical analysis of orbital mechanics and debris propagation, and what his equations showed was terrifying in its simplicity. When you put enough objects in orbit, collisions become inevitable. Not just possible, inevitable. It is a matter of pure probability. The more objects there are, the more likely any two of them are to occupy the same point in space at the same time. And at orbital velocities, when two objects meet, they do not bounce off each other. They shatter. A single collision between two satellites can create thousands of debris fragments. Each fragment is itself a potential impactor. Each fragment will circle the Earth for years or decades before atmospheric drag finally removes it. And during all that time, each fragment has its own probability of hitting something else. Kessler realized that beyond a certain threshold, this process becomes self-sustaining, a runaway cascade of collisions that feeds on itself. Each collision makes the next collision more likely because each collision adds to the debris population. Each destroyed satellite adds to the cloud of fragments that threatens remaining satellites. The process accelerates over time rather than stabilizing. Once Kessler syndrome begins in earnest, it cannot be stopped by any technology we currently possess. We cannot shoot down debris because shooting creates more debris. We cannot sweep it up because we have no space garbage trucks. We cannot push it out of the way because we have no way to grapple with tumbling fragments traveling at 17,000 miles per hour. We can only watch as the cascade plays out over years or decades, gradually rendering low Earth orbit unusable for generations. Some estimates suggest that if Kessler syndrome fully develops, low Earth orbit could remain unusable for centuries, not decades, centuries. The debris would slowly decay due to atmospheric drag, but the process would take hundreds of years. During that time, humanity would effectively be trapped on Earth. No weather satellites, no GPS, No communication satellites, no space stations, no missions to the moon or Mars. Our access to space, earned through decades of effort and trillions of dollars of investment, would be gone. Are we already in the early stages of this cascade? SpaceX's 200% increase in collision avoidance maneuvers suggests we might be. The fact that they are executing 800 maneuvers per day, one every 2 minutes, suggests that the density of threats has already reached crisis levels. The fact that they are relocating half their constellation in an emergency operation suggests that the situation at 550 kilometers has already become unacceptable. And yet, even as SpaceX scrambles to move their satellites to safer orbits, the launches continue. Not just from SpaceX, from everyone. The race to occupy orbital real estate has become a gold rush, with nations and corporations competing to stake their claims before the available slots run out. Amazon's Project Kuiper plans to deploy thousands of satellites starting this year. They have regulatory approval for over 3,000 spacecraft in their initial constellation, with plans to expand to 4,700 and beyond. Jeff Bezos has invested billions into this project, viewing it as critical infrastructure for the future of e-commerce and cloud computing. Their target orbital altitude is between 500 and 600 kilometers, right in the zone that SpaceX is trying to evacuate. Amazon is running toward the danger that SpaceX is running away from. China has announced plans for satellite constellations totaling over 10,000 spacecraft. The Guowan constellation alone is planned to include nearly 13,000 satellites. China views space infrastructure as critical to national security and economic development. They are not going to slow down because American companies are having debris problems. If anything, SpaceX's difficulties might be seen as an opportunity to catch up. The European Union is developing its own sovereign constellation called IRIS², designed to provide secure communications independent of American infrastructure. After watching SpaceX provide critical support to Ukraine, European leaders realize they cannot depend on foreign companies for strategic communications. They are planning hundreds of satellites in the initial phase. India has plans for broadband constellations. South Korea has plans. Japan has plans. Rwanda has filed for orbital slots for over 100,000 satellites, likely as a placeholder for future commercial ventures or to lease slots to other operators. The question is not whether orbital space is becoming crowded. That question was answered years ago. The question is whether we have already passed the point where we can manage the crowding, whether the debris population has already reached a level where cascading failures are inevitable regardless of what we do now, whether all these planned constellations will ever actually fly, or whether the orbital environment will become too dangerous before they can be deployed. Here's a fact that does not appear in press releases but keeps space operations experts up at night. Every satellite eventually fails. Every single one. The question is never if a satellite will fail. The question is when. Average satellite lifespans are measured in years, not decades. Components wear out, solar panels degrade, batteries lose capacity, thrusters run out of fuel, electronics are damaged by radiation. When a satellite fails, if it cannot be commanded to deorbit itself, it becomes debris. A large, uncontrolled object tumbling through orbital space for years until atmospheric drag finally brings it down. And if Kessler syndrome is already beginning, each new dead satellite does not just add one piece of debris. It adds a target that, when hit, will multiply into hundreds of pieces. SpaceX has been relatively good about deorbiting their failed satellites. They designed the Starlink spacecraft to decay quickly if they fail, but not every operator is as responsible, and not every failure gives the operators time to command a controlled deorbit. So what do you think about all of this? Is SpaceX doing the responsible thing by moving their constellation to a lower, safer altitude? Or are they simply making room for the next wave of satellites, clearing the valuable 550-kilometer zone so others can fill it? Are they solving the problem or just delaying the inevitable? Should there be international limits on how many satellites one company can operate? Right now, there are no such limits. SpaceX could theoretically launch another 10,000 satellites if they wanted to, and no international body could stop them. The Outer Space Treaty of 1967 establishes that space is the common heritage of all mankind, but it provides no mechanism for managing orbital congestion. And here is perhaps the hardest question of all. If an American company's satellites collide with a Chinese launch vehicle, creating debris that damages a European Space Agency spacecraft, who is responsible? Who pays for the damages? Who cleans up the debris? There is no clear answer. International space law has not evolved to handle these scenarios. The Liability Convention of 1972 establishes that launching states are responsible for damage caused by their space objects, but determining which debris fragment came from which spacecraft becomes nearly impossible once a cascade begins. Debris from a 1995 Russian rocket stage might hit an American satellite, creating fragments that hit a Chinese spacecraft, creating more fragments that damage European infrastructure. Tracing the chain of liability would be a lawyer's nightmare and a diplomat's impossibility. SpaceX says this reconfiguration will take all of 2026. They are coordinating with other operators and U.S. Space Command to ensure the maneuvers themselves do not create additional collision risks. Thousands of orbital adjustments, carefully sequenced to avoid creating the very problem they are trying to escape. And when it is done, what happens to the orbital zone they left behind? That 550-kilometer shell, now with 4,400 fewer SpaceX satellites but the same amount of debris, what becomes of it? Does it become too dangerous for new satellites to operate there? Does the debris continue to accumulate without active satellites performing avoidance maneuvers? Or do other companies, seeing newly vacated orbital real estate, rush in to claim the space? The answer might determine whether SpaceX's emergency relocation was a solution or merely a postponement. Within 5 years, we will know. By 2031, we will see whether the debris population stabilized or continued growing. We will see whether Kessler syndrome was averted or merely delayed. We will know whether humanity managed to govern a shared resource that has no borders and no policemen, or whether we destroyed one of our most valuable assets through collective short-sightedness. The stakes could not be higher. Modern civilization depends on satellites in ways most people never think about. We have woven space infrastructure so deeply into the fabric of daily life that most people are completely unaware of how much they rely on it every single day. GPS navigation does not just guide your car to unfamiliar destinations, it synchronizes cell phone towers so your calls connect properly. It timestamps financial transactions so banks can process millions of trades per second. It guides tractors across fields with centimeter precision, increasing crop yields. It helps aircraft land in fog. It tells container ships exactly where they are in the middle of the ocean. Weather forecasting depends on satellites watching cloud formations from above. Without those eyes in the sky, we would have no warning of approaching hurricanes. Farmers would not know when to plant or harvest. Airlines would not know which routes are safe. Emergency managers would not know where to evacuate. Financial markets depend on satellite timing to synchronize trades across continents. Billions of dollars move every second based on timestamps that must be accurate to microseconds. Remove that timing and global finance becomes chaos. The internet itself increasingly depends on satellite infrastructure, not just for remote areas. Undersea cables carry most intercontinental traffic, but satellites provide critical backup and serve regions that cables cannot reach. Starlink alone serves millions of users who have no other option for broadband access. Military operations depend on satellites for communications, navigation, reconnaissance, and early warning. The precision-guided weapons that define modern warfare are guided by GPS. Remove the satellites, and military capabilities return to World War II levels. Scientific research depends on satellites for climate monitoring, astronomical observation, earth science, and countless other applications. Our understanding of climate change comes largely from satellites measuring ice sheets, ocean temperatures, and atmospheric composition from orbit. All of it depends on orbital space remaining usable. All of it is at risk if we cannot solve the debris problem before the cascades begin. The next time you use satellite internet, the next time you open a Maps application on your phone, the next time you watch a weather forecast, remember what you learned today. You are relying on a system that is one bad day away from catastrophic failure. A system that requires 800 collision avoidance maneuvers per day just to keep functioning. A system that one of its largest operators just declared an emergency and began evacuating. We have built our civilization on a foundation that we may not be able to maintain, and the clock is ticking. Solar minimum begins in 2027. The natural debris clearing that has helped manage orbital congestion will slow dramatically. Every satellite that fails after that point will stay in orbit longer, creating risk longer, potentially triggering cascades that cannot be stopped. SpaceX has 12 months. Humanity might have only slightly longer. Thank you for watching. If this information matters to you, share it. The more people understand what is happening 500 kilometers above their heads, the more pressure there will be for solutions, for international cooperation, for responsible space operations, for the governance systems we desperately need but do not yet have. Leave your thoughts in the comments, because this is not just an engineering problem anymore. It is a question of how humanity governs shared resources when there are no borders, no enforcement, and no second chances. The decisions we make in the next few years will determine whether our children inherit access to space or inherit a sky filled with so much debris that leaving Earth becomes impossible. What would you do if you were in charge? How would you balance the benefits of satellite services against the risks of orbital congestion? How would you enforce international agreements when some nations refuse to participate? These are not hypothetical questions for policy seminars. These are decisions that must be made now, in real time, while the debris population continues to grow and the solar minimum approaches. Some experts have proposed a moratorium on new satellite launches until debris removal technology matures. Others say that would be economic suicide for companies that have invested billions. Some suggest a tax on satellite launches to fund debris removal. Others say that would simply push launches to countries with no such taxes. Some propose international treaties with teeth. Others point out that the nations most responsible for debris have no incentive to sign. There are no easy answers, but there are consequences for inaction. And those consequences are measured in cascades and centuries. Until next time, keep looking up. But maybe with a little more concern than you had before. And maybe, just maybe, with a commitment to demand better from the companies and governments whose decisions will determine whether space remains accessible for future generations.